This is Unit 4, Pre-Cal, Combining Functions, Practice Test. All right, we start with number 1. We have the following graphs, or the following depicts the graphs of f of x equals x minus 2 squared minus 3, and g of x equals x plus 2. We can tell when we expand this out that this is a quadratic equation, so we're going to have that U shape, and it is going to, when we graph it out, it's going to represent this, and then this is a linear equation. Okay, so we're going to graph those two. You can use Desmos to do that. And then we're going to add those two functions together. So you can make a table, and you can pick some coordinates that are on f of x, and then also are on g of x. Okay, match up the x values, add the y values to find a coordinate for f of x plus g of x, because we're combining with addition. All right, so I picked negative 2, 12, 0, 1. Okay, that matches up with 0, 2, 0, 1, and 0, 2. I picked 4, 1 on f of x. That matches with 4, 6, and 6, 13, 6, 18, 2, negative 3, 2, 4. All right, keep my x values the same, add the y values, and that gives me points to plot for f of x plus g of x. So I'm going to plot those points, I'm going to connect the dots, and I want to see this work on your paper, but you can use Desmos for these. All right, so for this function, f of x, f plus g of x, okay, if I go ahead and expand this binomial, I'll get a trinomial. Go ahead and fold it out, x squared plus 4x plus 4, and then minus 3. Okay, that combines together to give me x squared minus, and I'm going to, what do I have over here? Plus x plus 2. So we've got to add that on as well. All right, because we're adding those together. So we have 1x squared. Negative 4x plus 1x is negative 3x, and then 4 plus 2 is 6. Check this work, make sure it's correct. Oh, that's negative 4. Negative 4 plus 2 is negative 2. All right, double check this equation again. Again, take this and f of x and g of x, add them together. So we're going to have to expand this, boil it out. Don't forget the minus 3, and then add this x plus 2. All right, and then this may not be correct. I'm just looking at it quickly. I'll go back and check that. All right, you can also graph these to see, so it's going to be easy for you to plot. I want you to get this equation on your paper, and then determine the domain and the range. So you can see that the domain for the new function, the combined function, can be any value. X can be any real number. And the range is going to be from y greater than 1. So it starts at 1, and then any value greater than 1 in the set of real numbers. All right, let's go to number 2. We're going to be doing the same thing. We have the same two functions. We're going to be subtracting them. So once you have this x minus 2 squared foiled out, you're going to use that. And I'm seeing some mistakes in this. So go back and work through this carefully. So we have x squared minus 4x plus 1, and then minus 3. Okay, I didn't make this. I'm just going through this. And then minus x plus 2. Here's the important part. We're distributing a negative. So that's going to be negative x minus 2. And then combine like terms, see what you come up with. Make a table of a few points that match up with G and X. That will also help you plot. Okay, on the test, I need to see this, and I need to see this. You can graph to get this and check your work. Okay. All right, so for the third graph, make sure I have it up high enough. We're going to be sketching the graph, the new graph P of X, and we get that from multiplying f of x times g of x. So to put this in your calculator, you're going to put these two functions in separately, and then you just say f of x plus, minus, or multiplication or division. This time we're multiplying. So f of x times g of x once you have the equations in your calculator. Now we want to determine a new function p of x, which is, okay, p of x, which is, where was I? From multiplication, which is both of these multiplied together. So it's f times g of x. All right, so once you have that first one FOILed out, don't forget the minus 3, and then we're going to put multiply it times x plus 2. All right, so go back and look at this work. I don't know if I'll have time to redo it before making a video for you, but work it out. Know how to come up with the table of values in case you're asked anything about how do you make a table of values, how do you combine them with multiplication. Again, we don't do anything with the x's, we multiply the y's. Use your operation and only operate on the y part of that coordinate. All right, looking at your graph, we can see the domain is x, such that x can be any real number. For that new graph, we're looking at that new graph, okay? And y can also be any real number, because our new graph, I pointed to this one, is going to be a cubic this time. Okay, so it starts here, down in negative infinity, goes up, down, so we have a max here and a min here, but then it goes back to positive infinity. So this time the range can be any real number. Okay, this part, the fourth graph, we're going to sketch the graph of the quotient. Okay, so once we have these two functions in our calculator, we can just put in f of x divided by g of x to get the graph. Okay, also remember how to come up with points if you're given a question and involves points. Remember that we're only operating on the y part of that coordinate. Okay, so this table gives you some things to look at, how to match up points. But I can see right here, when I go to -2, it's undefined. So that tells me that I have an asymptote at -2, x equal -2. So make sure to draw that in, because Desmos won't show you that asymptote. All right, and we know it's at -2 because now with division, you have to look at the denominator. You have to set that equal to 0 and solve for x. So we'll be subtracting 2 from both sides. So when x is equal to -2, you have no solution. That gives you your asymptote. Okay, this time we've got to write the domain so that we have all real numbers except for -2. So you've got to omit that with not equal to. And then the range, you can see the range goes from negative infinity to positive infinity, all real numbers. The range is the harder one for me to look at and see, so practice with that if you need to. All right, question number 2. Trying to make sure that I see this. All right, given that f of x equals 5x plus 1 and g of x equals -x minus 4, write an explicit equation for h of x equals f of x minus g of x. Determine the domain and range without graphing technology. All right, so it's the same thing that we did before. Okay, so we have these two functions, but we're not going to use graphing technology. We're just going to do it on our paper. All right, so we have 5x plus 1 minus, put parentheses around this because we're subtracting both terms. So when you take away a negative, you get a positive. Or when you distribute -1, these signs are going to change. So it's going to become plus a positive x and a positive 4. All right, combine those together and then look at the domain. All right, this is a simple linear function. So the domain is the set of all real numbers. And the range is such that y is the set of all real numbers. Because when we have a slope and an intercept, it intercepts at 5, it slopes, it goes up 6 and over 1. So it's going to look like a line with a positive slope. So the range is all real numbers and the domain is all real numbers. Number 3, we're given 4x squared plus 3. For f of x and g of x is 2x minus 3 and h of x equals 1 minus x cubed. We want to write an explicit equation for k of x, and that's going to equal to f of x times g of x. We do the multiplication first, and then minus h of x. All right, so let's put these first two functions, f of x and g of x, 4x squared plus 3 times 2x minus 3. So we have two binomials. So you can FOIL those out. If you need a table, make a table. So this is going to be 4x cubed plus 6x minus 12x squared. And the last term is -9. Okay, and then minus, again, we're distributing that negative to both terms. Minus, that's not an x here, that's -1. So remember that these review answers for you can contain mistakes. So you do your own work and ask questions if these don't match, okay? All right, negative times a negative is a positive, x cubed. So now let's combine like terms and put these in order. So I've got 8x cubed plus 1x cubed is 9x cubed. Okay, let's look at our x squareds. Negative 12x squared comes next. And then let's look at our linear terms. 6x. And that's not an x here. They subtracted it, so it should be 6x here. And again, check me to make sure I'm not missing anything. And then -9. All right, so let's see here. That's a cube, that's a squared. That looked like a cube, so let me make it clear. All right, our domain, it's a quadratic, is the set of all real numbers. And our range is y, such that y is an element. Y is an element of all real numbers. Check this as well, okay? Now, I know if it were quadratic, y would have a restriction. It would start somewhere. It would either go up or down, depending on the graph, whether you have a negative in front or a positive. But this is a cubic, so it's either, when it's positive, it starts in the third quadrant, and then it goes up. The end behavior is down in the third quadrant, up in the first quadrant. So that's a set of all real numbers for cubic. All right, question number 4. We have a function square root of x plus 2 for f of x, and g of x is x minus 3 squared. We want to write an explicit function equation for q of x equals f of x over g of x. Okay, then determine its domain and range. So we're dividing this time. Okay, and it says without graphing technology. So let's just go ahead and do it algebraically. The square root of x plus 2 over x minus 3 squared. All right, now we can't have a 0 on the bottom, so we're going to have an asymptote when x minus 3 equals 0. So we'll have an asymptote at x equals 3. And again, we can define the domain with x such that x cannot equal to 3. And x is greater than or equal to -2. Okay, x is an element of the real numbers. All right, this says do it without graphing technology because I want to see your algebra first, but you're going to be able to use graphing technology and you'll be able to see where your asymptotes are or where any restrictions are. We have a restriction here, not because we have anything in the denominator, but in the numerator, we can't graph negative or imaginary numbers. All right, so this can be 0 or greater. So if this is -2, we have a 0. So x is greater than or equal to -2. And again, you'll have your graphing calculator throughout the test, so you can check your answers as you go. All right, number 5, given the graphs of y equal f of x and y equals g of x, determine the values of f of g of 1 and g of f of 1. All right, let's see. I can't see which one's which. All right, I think this is f of x. They both look like f of x. Let's say this is f of x and this is g of x, and let's see if we're right. All right, so we want f of g of 1. So we're going to go over to 1 and up to 3. So we get 3. Then we're going to put that into f. So over to 3 and then up to 7. Okay, so maybe I did that backward because they got 5. All right, let me look at the test and see what it says. Much clearer on the test. All right, so we're going to work inside out. G of 1 is, here's G. All right, so G of 1, still hard to see. Is that 2? You go over to 2 and then up to 1. Well, let me take a closer look at that one. I'll rework this one again because I don't know how they got 5 and they're not showing their work. All right, let's look at this one and see if it's, let me see, they said G of 1 equals 2. I'm not sure if I agree with that. There it is, G of 1. So this must be G. G of 1 equals 2. And then I go over to 2, and then I go up to 5. All right, so that's how they got that. G of 1 is 2. Put that 2 into function f. Okay, f of 2, so we're going to go up to f of x is 5. Okay, now I see it. It's just tiny, tiny. All right, f of 1. Okay, let's see which one's f. F is the one that has a positive slope. So f of 1, I hope you can see this, is 1, 2, 3. Okay, we're going to put that into G because we're starting on the inside and going out. So once we have 3, we're going to go over to 3, 1, 2, 3. And then we're already on the line and we get 0. All right, question number 6. Given the functions f of x equals 2x minus 3 and g of x equals x squared minus 1, determine each value below, f of g of 1. Okay, so we're going to work from the inside out, this time algebraically. Put 1 into g of x So you have 1 squared minus 1, you get 0. Put that 0 into function f. Function f is 2x minus 3. So 2 times 0 minus 3, and you get a negative 3. So f of g of 1 is negative 3. This one's done algebraically. Okay, we are going to complete this. I haven't quite decided yet. I think I'm going to have it on paper and a place. Give me just a minute with these lights. Okay, and a place to input your answer. All right, for B, we want to find f of 1. All right, so we're going to plug 1 into function f. So we get 2 times 1 minus 3. That equals negative 1. Okay, so let's put that negative 1 back into function f. We get 2 times negative 1 minus 3 equals negative 5. So f of negative 1 equals negative 5. All right, that was question number 6. We're going to move on to question number 7. All right, given the functions f of x equals x squared plus 3x minus 1 and g of x equals 5x plus 3 over x minus 1, we want to determine each value. So we have f of g of negative 3. All right, so this is going to be algebraically. We're going to have a paper test, so I need to see this part worked out. So we're going to start with g of negative 3, plug it in, get your answer. We get 3, plug that into f. Okay, solve it algebraically, and you should get 17. Let me know if you get a different answer so we can correct that for everybody. All right, B, we have g of f of 2. So we're going to plug 2 into function f. And when we do that, we get 9. And then take that 9 and plug it into function g, and we get 6. Okay, same thing, practice your algebra. Take your time, know what you're doing before you take the test, because I need to see those steps along with your answer. So I want to give you credit where I can give you credit. All right, number 8, f of x equals negative 3x minus 2 and g of x equals 2x squared plus 4. We want to determine an explicit equation for each composite function below. So we're doing the same thing. So f of g of x, okay, we're going to take g of x, 2x squared plus 4, okay, and we're going to plug that entire expression into f where you see an x. So we start with negative 3 times, now we plug that in, 2x squared plus 4. Don't forget the minus 2. Simplify that, and we get 6x squared minus 14. This is a quadratic function, and when you graph that, okay, it looks like this. We've identified the vertex. I'm not going to ask you to remember that formula. At this point, you can look at your graph to find the vertex at 0, negative 14. So the domain, your x's, can be any real number. Your range this time is y less than or equal to negative 14. It's also in the set of real numbers. All right, part B. All right, we want f of x. So we're going to take f of x and plug it into itself where you see an x. So negative 3 times negative 3x minus 2 minus 2. Distribute that negative 3. Do it correctly, and again, double check my work. I can't guarantee you that my work doesn't have errors in it, so let me know, point it out if you see something, so we can let everybody know before we take our test. But you need to be doing your own work as well. Negative times a negative is positive. Okay, we only have one x, so that's positive 9x. Negative times a negative is positive 6, and then we have the minus 2. So this is a linear equation when you combine the constants, 9x plus 4. The domain and the range are the set of all real numbers. All right, question number 9. We have the function 6x plus 4. That's f of x, and g of x equals the square root of x plus 5. we want to determine an explicit equation for g of f of x. So we're putting f of x into g of x. So we're going to start with f of x. So let's find what that is. That's 6x plus 4. We're going to plug it in every time you see an x. So this is the square root of 6x plus 4 plus 5. You get the square root of 6x plus 9. Okay, and we're going to solve this by subtracting 9 from both sides. And you get 6x equals negative 9. Divide both sides by 6. X equals negative 3/2. All right, the domain and the range. I'm not sure why they're dividing by 6. I'll take another look at that. Dividing everything by 6. The domain is the set, or I guess we're looking at everything that x can be. So if we divide by 6, we get 6 times x plus 3 over 2. Okay, we can't let that be a negative number. Okay, so I see what they're doing there. They're solving this so that we're eliminating negative numbers. So x has to be greater than or equal to 3/2. So if this is 0, this makes the whole thing 0. So we're factoring out a 6 to get that coefficient 1. When that coefficient is 1, we set this factor equal to 0. So x has to be greater than or equal to 3/2. That's what 9 over 6 is in the element of real numbers. All right, number 10, given the functions f of x equals 1 over x plus 6 and g of x equals x squared minus 5x, determine an explicit equation for each composite function, then state its domain. All right, f of x, we want f of x plugged into, we want x plugged into f of x first. F of x is plugged into g of x. Okay, so f of x is 1 over x plus 6. Okay, we're going to plug that into g of x. So where you see an x, you're going to put 1 over x plus 6. We're going to square that minus. Where was I before the lights went out? Square that, and then minus 5 times x. Okay, so we're going to put 1 over x plus 6 right here, multiply by 5. Okay, and you can see the work, or maybe you can't see the work. I didn't work it out here, but you go ahead and work it out. This gets you a start. So you can see the domain is x, such that x is not, because we have these denominators, the domain is restricted. We have an asymptote at x equals negative 6. Set that equal to 0 and solve in the set of real numbers. All right, so I guess that's why I didn't do any further, because we already have that set up with the denominator. If I distribute, I'm still going to have the same denominator. It's not going to change anything. This will just make this quadratic and harder to see. Okay, so x cannot equal to negative 6. All right, B, we have f of g of x. Okay, we're going back to these functions. All right, so we'll start with g of x, x squared minus 5x, and put it into f of x. So 1 over x squared minus 5x plus 6. All right, go ahead and pull this down and then factor into 2 binomials. So if you need help or review in factoring, let me know. But we have x minus 3 times x minus 2, because the two factors of positive 6 that multiply to give you a positive 6 and add to give you a negative 5, or negative 3 and negative 2. All right, so x cannot equal to, if you set this equal to 0 and solve, cannot equal to 3 or 2, and it's in the set of all real numbers. That's your domain restriction. All right, question number 11. All right, we're using this function, and it is hard to see. Sorry about that. Let me go back to my test. All right, we're going to use the function k of x equals x squared plus 4x plus 3 and write explicit equations for three functions, f of x, g of x, and h of x, so that k of x equals f of x plus g of x plus h of x. So we're deconstructing. Okay, this is where you can come up with your different solutions. So let me show you what I've got. Okay, I let f of x equal x squared, okay, because I need that term, and g of x equal 4x, and h of x equal 3. So when you add those together, we're using addition here, you get back that original equation. So a little bit of thinking here, but you can have different answers as long as they add up. Those three functions add up to your original function. All right, B, write an explicit equation for two functions, f of x and g of x, such that when you subtract them, you get back x squared plus 4x plus 3. Okay, so f of x equals x squared, and g of x equals negative 4x minus 3, because when you subtract negatives, these become positive. All right, part C. Now we want two functions so that when you multiply them together, you're going to get that original equation. So I broke this into f of x equals x plus 3 and g of x equals x plus 1. I simply factored it and got the two binomials that when you multiply them together, you get that trinomial back. All right, number 12, we're given the sketch f of x equals x plus 3 and g of x equals x squared minus 3. For each composite function, we want to sketch a graph of the function and state its domain and range. Okay, this is number 12. Not sure if you're seeing this or not. Okay, so we have A, f of x, and B is f of g of x. All right, so I made a table. However you do it, I want you to show your work on your paper. Okay, and then I combined the y values, okay, to get f. Let's see, here's f of x. This is not combining them. This is just finding f of x. And then g of x. So I have x and y values for both. X, here's my x, matches up with my y. Here's my x, matches up with my y. So when I'm adding, I can see I get, if I add these two functions, I get negative 2, 5, negative 1, 7, 0, 9, 1, 11, so forth. Okay, quick review of the review. Let me know if you have any questions, and your test is on Friday. All right, thank you.